Hello everyone. Today we are going to see the topic monosaccharides. So some of the examples of monosaccharides are glucose, fructose and galactose. So first we want to see glucose. Glucose also called as aldohexose and dextrose, and it is abundant on earth, and it is named as D-glucose, and D represents the configuration where plus represents the dextrorotatory nature of the molecule. So the glucose may be of ring structure than open chain structure. The two cyclic structures differ in configuration of the hydroxyl group at C1, which is termed as anomeric carbon. Such isomers, that is alpha and beta form, is known as anomers, and the cyclic structure is called pyranose structure due to its analogy. So this is a cyclic structure of glucose where D-glucose and D-mannose is represented in the following figure, where alpha and beta groups also included in this. Coming to the fructose, it is an important ketohexose, and the molecular formula for fructose is C6H12O6, and it contains the name itself indicates the ketone, so it has ketonic functional group. The ring member of fructose is an analogy to the compound furan, and it is named as furanose. So this is the cyclic structure of fructose, D-fructose and alpha D-fructopyranose structure. Coming to the galactose, it is a simple sugar belonging to simple carbohydrates, and it is a orderless white solid, and the molecular formula is C6H12 and O6. Galactose is a monosaccharide, and it is also an epimer of glucose, and most of the galactose is ingested by humans, which it gets converted to glucose. So galactose thus binds to glucose molecule, thus makes the lactose, and to lipids to make glycolipids, and to proteins to make glycoproteins. So this is the structure of galactose, and it is also exist in open chain as well as in cyclic form. So chain form of galactose is which is similar pattern like glucose. Coming to the properties, molecular formula C6H12O6, and molecular mass is 180.156, and the melting point is 168 to 170 degrees Celsius. So coming to the lactose, so it is an example of disaccharides. So lactose is a type of carbohydrates. It is also called milk sugar and lactobacillus, and it is a disaccharide as I said before. It is synthesized from galactose and glucose subunits. So the lactase, which is the enzyme, breaks lactose into glucose and galactose, and it is absorbed in intestine, and it is further used in food industry, bacterial identification and pharmaceutical industry. So the molecular formula of lactose is C12H22O11, and it is soluble in water. Milk contains 2 to 8% of lactose by mass, and it is found in mammary glands of all mammals, and very small amount of lactose can be found in dairy products like cheese and yogurt, and it is less sweet when compared to glucose. So this is a lactose structure. It's a disaccharide sugar formed by beta 1,4 glycosidic linkage of beta D glucose and beta D galactose. So coming to the preparation, lactose prepared from whey permeate. Whey is comprised of 6.5% solids, of which 4.8% is lactose, which is crystallized and purified. It can also be extracted by diluting whey with ethanol. So physical properties, as we know, it is orderless, sweet, density is 1.525, and melting point is 252 degrees Celsius. Soluble in water and very slightly soluble in alcohol, and insoluble in ether and chloroform. So these are all the chemical properties of lactose. C12H22O11 plus H2O gives glucose and galactose, that is C6H12O6, and it undergoes hydrogenation and it is isomerized in alkaline solution to produce lactulose. Thank you.